Okay, we're going to work on the Unit 2 review. I've gone ahead and pre-filled a few of these just so I don't have to write them out while I'm going through this. So let's give it a go. If an angle has a measure between 0 and 90, then it is an acute angle. Keep in mind that between 0 and 90 does not include 0 and 90. So anything greater than 0 or less than 90, so that is true. Our converse is if y then x, so we're going to flip those around. Sorry. If an angle is an acute angle, then it has a measure between 0 and 90. Our inverse, if not x, then not y. If an angle does not have a measure between 0 and 90, then it isn't an acute angle. That is true. Our contrapositive, if an angle is not an acute angle, then it doesn't have a measure between 0 and 90, and that is true. So if we can write a conditional as a biconditional, remember that these first two must be true. And since that is the case, we can write a biconditional. Remember, we're going to remove the if and then and replace it with if and only if in the middle. An angle is acute if and only if its measure is between 0 and 90. You could also flip-flop that. An angle's measure is between 0 and 90 if and only if it is an acute angle. If two angles are congruent, then they are vertical angles. So our question here is this true? I know this to be false because I don't have to have angles to be congruent as vertical angles only. So if we have, let's say, an isosceles triangle, and I know that these two angles are congruent, those are not vertical. Our converse, if two angles are vertical, then they are congruent. That is true. Vertical angles are always congruent. If two angles aren't congruent, then they aren't vertical. That is also true. They have to be congruent if they are vertical. If two angles aren't vertical, then they aren't congruent. That is also false. See that case above. So we cannot write our biconditional statement because not both are true for your original and your converse. Angles don't have to be vertical to be congruent. So you could use your triangle as a picture up there, or two 90-degree angles on a straight line. There are multiple examples that you could have there to prove that to be false by one counterexample or another. The average of any two consecutive even numbers is an even number. Well, let's take two consecutive even numbers. If I take 2 plus 4, that is 6, and 6 over 2 is 3. So the average of two consecutive even numbers is always going to be that odd number right in the middle. If a figure is a rectangle, then it is a square. We can draw us out our counterexample that looks like a rectangle. And again, like we talked about in the notes, make sure that you have more than enough info in there to make sure that everybody knows that this is a rectangle that is not a square. We're going to write this statement as an if-then. We're going to underline the hypothesis once and the conclusion twice. So plastic objects are durable. We could put something like, if an object is plastic, then it is durable. If an object is plastic, then it's durable. So we're going to underline our hypothesis once. That's this beginning piece. And our conclusion, you can underline the if and then. You don't have to, but you can. All right, list the next two terms in this pattern. I can see we go 1, 1, 2, 2, 3, 3, 4, 4. So I'm going to have 5, 5, and 6, 6. 3, 4, 5, 6, 7, 8. It's just one way to go about it. 4, 6, 9, 13, 18. We add 2, add 3, add 4, add 5. So I'm going to add 6 for the next one, which would bring us to 24, and add 7 to the next one, which would bring us to 31. Here I am multiplying by 3, but not only by 3, I'm also flipping the sign, so I'm multiplying by a -3 each time. So a negative 81 times 3 would give us a negative 243. And if I do 243 times 3, that will give us 729. And then if we look at our signs here, a negative times a negative gives us a positive 243 and a negative 729. Sketch the next pattern, the next figure in the pattern. So I've got 2 pieces, 3 pieces, 4 pieces. Just do the best that you can. And we're going to have here 5 pieces. So let's see, 2, 3, 4, 5, close enough. It doesn't have to be perfect. I know what you're going for here. All right, so here are our blocks. Notice that with each step I have 1, 2, 3, 4 shaded blocks. So in the next one I'm going to have 5 shaded blocks, and it just so happens that the newest shaded one belongs on the bottom. So I'm going to go through all of this. I'm going to have 6 total. And shaded, shaded, shade, and shade. All right. Determine from the figure whether the following statements are true or false. Points A, B, D, and J are coplanar. So here is A, B, D, and J. The answer to that is yes, they all lie in plane K, which is shown there. All right, angle EBA is a right angle. Well, looking at our diagram, we can see that we don't have any type of perpendicular markings, so this is going to be false. Points E, G, and A are collinear. Remember that any 2 are always collinear, but if we have got 3, we've got to check and see if a line is drawn. So E, G, and A, this is false. Again, this word perpendicular, nothing here in the diagram shows anything to be perpendicular, so that is false. ABD and EBC are vertical angles, so ABD, that's this one here, EBC, that's this one here, those are indeed vertical angles. Planes H and K intersect at line AB. So this is the gray plane and the white plane at line AB, and that is true. You could name that line a couple of different ways, but line AB is one of them. FG and DE intersect. That cannot be concluded. And angle GCA, so GCA here, and CBD are congruent, and we cannot make that assumption either. All right, so for our properties, we're going to be looking for something like, we're going to be having our reflexive, transitive, addition, and so on and so forth. So reflexive property of an angle measure. Remember, this is the same thing on both sides, so this is going to be the measure of angle B is equal to the measure of angle B. Our transitive property is if CD is equal to GH and GH is equal to RS, then CD is equal to RS. You could also make this one CD, and that would be fine. So our addition property of equality, back up to that top one. If you use that CD, then the result would be that, let's see, GH would equal RS, just as a side note. A couple of different ways to do that. So our addition property is where we add the same value to both sides. So if I am adding 14 to the left-hand side, then I'm going to add 14 to the right-hand side. You could either put 3 plus 14, or you could also put 17 there. Symmetric property. This is where we flip-flop them. So if BC is equal to RL, then we can reverse those. RL is equal to BC. Our substitution, if the measure of angle A is equal to 35, then 3 times the measure of angle A is equal to 3 times 45. Don't go any further, just replace it. One step. So multiplication property, if I do the measure of angle A is equal to 45, then 1/3 of the measure of angle A is equal to 15 degrees. You could also see this as 1/3 of 45 is where we're getting that from. All right, so our proofs. We're going to start out with our given statement, and we're going to take a look at what's going on. So what's changing from step 1 to step 2 is we are distributing that 5. So you could put distribution, you could also put distributive. Be sure to follow what's happening and what they are moving. So in this case, we are moving the 5 through addition. And then we are subtracting the 9x. Next proof, we are given that AB is equal to BC. So AC is equal to AB plus BC. If I trace that, this is 2 shorter ones, add to give me the longer. So this is our segment addition. And AC is equal to AB plus AB. So when I look up above, I see that this BC has changed. And it has changed because AB is equal to it. So this is our substitution. And in the next one, I am combining. So you could use, it's almost like an undistributive property, but I have seen distribution used here. I have also seen combine like terms or simplify. All right, BE bisects angle ABD. So I'm going to go ahead and mark that. BE bisects angle ABD. ABD, so that is here and here in our given. And BD bisects angle EBC. I'm going to go ahead and put that one in here. All right, so angle ABE is congruent to angle EBD because that angle is being bisected. So that is our definition of an angle bisector. EBD is congruent to DBC. That is the same definition of angle bisector. And ABE is congruent to DBC. It's a bit jumbled up here, but this is our transitive property of congruence. If 1 is the same thing as 2 and 2 is the same thing as 3, then 1 and 3 are the same. All right, here on number 28, I have a linear pair, and what I know about a linear pair is that they add to give us 180 degrees. So 3x plus 12 plus 48 will give us 180 degrees. 3x plus 60. So 3x is equal to 120, and x is equal to 40. All right, over here on the right-hand side, we're going to have a system of equations here. There's no other way around it. So one thing that I can do is set my vertical angles equal to one another. Y is equal to 2x plus 2. And I can set these two, or even these two, equal to 180. So I'm going to use the first set of, I'm going to use the first set of two. 13y plus 10x plus 2x plus 2 is equal to 180 degrees. So I'm going to go ahead and combine those. 13y plus 12x is equal to, subtract that, 178. And now we are ready to work some substitution. This one is set up nicely to substitute because y is equal to 2x plus 2. So I'm going to replace the y here with that. 13 times 2x plus 2 plus 12x is equal to 178. 26x plus 26 plus 12x is equal to 178. If I do 178 minus 26, that gets me 152. And 38x. So x is equal to 4. All right, if x is equal to 4, then I can go ahead and plug that in. 2 times 4 is 8. 8 plus 2 is 10. So then these are also equal to each other, so y is equal to 10. And the last set here, we're going to set it up with vertical angles so that we can keep all of our variables the same. So 9x plus 1 is equal to 13x minus 51. And whenever you go through the process here, we end up with x is equal to 13. And to set up our y's, I'm going to go ahead and multiply this out. So 2y plus 30 is equal to 4y minus 2. And we end up with y is equal to 16. Now pay attention on your test that if I'm asking you for the actual angle measures, that you go ahead and plug those back in.